Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we will be looking at statistics. In particular in this lesson, we will be focusing on frequency and frequency tables and how we can use these things to order our information. We will then look at something known as the cumulative frequency, and finally we will look at strategies and how we can measure the spread of information so that we can further analyse a group of data. So let's get started.
Ooh la la!
So to begin this lesson, we are going to have a look at frequency tables. And basically in statistics, a frequency table is just a way of helping us organise and order our data. So if we are conducting a survey or gathering information, then a frequency table would help explain this information in a better manner. So basically a frequency table consists of something that we are measuring, and this can be absolutely anything. It could be measuring people's ages, it could be measuring what they had for lunch, it could be calculating people's shoe sizes. Whatever it is what we are measuring, this normally goes in the first column of a frequency table, and in the second column we would often put how often it occurs, in other words the frequency of whatever we are measuring. So let's say for example we are measuring people's age or asking them how old they are, and let's say in this column we have the age bracket from 10 to 19, and there's 3 people in the group that's 10 to 19, then that means we would have 3 next to this age bracket. So in the right hand column we would have 3 and then the age that we're concerned about. So let's say for an example we wanted to conduct a survey of the shoe sizes of pupils in S1, and here are the results. So each number represents the shoe size of each pupil. So that would mean that if we have 1, 2, 3, 4, 5 shoe sizes, in other words 5 pupils, so that would be 5, 10, 15, 20, 25, 30, 35 pupils in this class. So here we have 35 shoe sizes for each pupil in S1, and it's our job to organise this information and put it within a frequency table. So the first thing that we have to ask ourselves is, what are we measuring? And of course it tells us in the question we are measuring the shoe size of pupils. And the way that we can define how we measure the shoe size or sort of categorise in this left hand column is totally up to our decision. So for example we could have just individual shoe sizes and we measure how often each one of they occur. But we could also have a column within this fashion here where each row represents a group of shoe sizes that we can measure. So example shoe sizes from 4 to 5, 6 to 7, 8 to 9 and so on. This decision is totally up to us, but we have to make a sensible judgment with the data that we've got. So for example I would say something like a shoe size, the numbers don't vary too much, so that means we're not going to have too many rows. So I think that it's unnecessary to group the numbers together like that, and we can just have individual shoe sizes. So what I would first do is look for the smallest number in our group, in other words the smallest shoe size, and from this group of data I can see that the smallest shoe size is 4 and the biggest shoe size appears to be 10. So that is the range that we're going to have our shoe size across. And always be careful when doing this task. Have a look at every row and every number so that we can see we're not missing anything and our range is correct. So now we have all our shoe sizes in place, it's now time to start dealing with the right hand column, and I've just changed the heading of the column to frequency because how often it occurs is also the same as the frequency, hence why we call it a frequency table. And there's many different ways of filling in this frequency section. Some people would maybe do tally marks like this, and some people would just go through the data and see how many there are of each shoe size and then fill it in with a number. But what I'm going to do is colour code each one of these and count how many we have and then write the answer within each of the rows and the right hand column. So beginning with 4, we only have one shoe size that's collected as being 4, so that means that the frequency of that would just be equal to 1. So next for a shoe size of 5, we can see here that we have 1, 2, 3, 4, 5 pupils with a shoe size of 5. For a shoe size of 6 we have 1, 2, 3, 4, 5 again. For pupils with a shoe size of 7 we have 1, 2, 3. For 8 we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pupils with a shoe size of 8. For 9 we have 1, 2, 3, 4, 5, 6, 7. And finally for a shoe size of 10 we have 1, 2, 3, 4, 5 pupils. So that's us now completed a frequency table. And because we said we had 35 pupils within the class, what we can do to make sure that we haven't missed any out is add up all of the frequencies that we've counted, and this should also be equal to 35. So here we have 1 plus 5 is 6, 6 plus 5 is 11, 11 plus 3 is 14, 14 plus 9 is 23, 23 plus 7 is 30, and 30 plus 5 gives us 35. So that means that we've done this correctly. And because we now have this information in a frequency table, it makes it easier to understand or visualise which students may have the most of a certain shoe size or the least. So we can see that from this table, the least amount of students have a shoe size of 4, with only 1 having a shoe size of 4, but the most would be 8 because we have 9 students with a shoe size of 8. So things like this and how we process the data, it's a little bit easier to understand since we have it now in a frequency table instead of just random numbers collected just like this. So this is just another example of a frequency table, and this time we are collecting the age of many individuals and the frequency, or in this case the number of people that fall into this age. But unlike the last time where we had just one number representing a row in the first column, we can see that this time we've grouped numbers together, so we have brackets, age brackets in this case, so we have ages from 11 to 20, 21 to 30 and so on. And the reason that we do that is because the range of possible ages that could fall into all of these categories is quite big. So imagine we had only like 11, 12, 13, 14, 15, all the way down to 70, then that means that our frequency table is going to be really long, and it doesn't have to be this long as well. So what we can do when we have a large group of data or a large group of variables that the input could be, so in this case it's ranging from 11 to 70, then it's good to group them together like in this fashion. But something like shoe size where the range isn't too big, in the last case it was only from a shoe size 4 to 10, then that means we're not going to have as much rows. So in that case it might be a little bit more sensible just to have individual numbers. So it's up to us to decide if it's more appropriate to form brackets like this, or just to have individual numbers representing each row. And if we wanted to display a frequency table in a nicer fashion, we could transform it into something called a frequency chart. So this is just a graph which has whatever we are measuring, in this case age, on the x-axis, so that's just all of these columns right here, and on the y-axis we have the frequency or the number of people, and each of the values of the number of people are just represented by each of these variables right here. So maybe we want to just display this information in a nicer way even again, and a frequency chart would be a nice way of doing this. So we said that when we were measuring shoe sizes, the frequency is just simply how often something occurs. So that means that we have 1 student with a shoe size of 4, 5 students with a shoe size of 5, 5 with a shoe size of 6, and so on. But we also have a different type of frequency, and it's called the cumulative frequency, and all that basically means is it's a running total of all the frequencies that occur. So basically with a frequency we're only counting how much or how many something occurs within its bracket, but with the cumulative frequency we're adding up the values as we go along, and it's not reset like we have here, so the values get bigger and bigger as we go along. So for example, for the first row here, the frequency would still be 1 because that's the first frequency that we encounter. For the second row, for the shoe size of 5 and a frequency of 5, the cumulative frequency would be 1 plus 5 because we're adding up the frequency before and also this one as well. So that would be 1 plus 5 is equal to 6, and then going on we would just do the same again where we add this frequency to all the other frequencies that occurred before it. So this time we have 1 plus 5 plus 5, and we can see that as we're going on the numbers are getting bigger and bigger, and finally for the final row the last value of the cumulative frequency should be equal to the amount of things that we were measuring. So in this case it was the shoe size for 35 different pupils, so that means that the last cumulative frequency is 35. And this is where the term a running total comes from, because we're adding on the frequency each time we go to the next row. So now we're going to move on to look at different ways in which we can further analyse a group of data. And one of the things that I've already touched on is the range. And the range is just basically a way of measuring how spread out the numbers are that we're collecting. And the way that we calculate this is the difference between the highest value of something that we're collecting and the lowest value. So going back to the shoe size example, we know that the largest shoe size that we were collecting was 10 and the smallest value was 4. So that would mean the value for the range would be 10 minus 4 because it's the difference between the highest and lowest numbers, and that would be equal to 6. So we can say that for this set of data, the range would be equal to 6. So let's say we've been given this task right here. We've been told that 10 pupils sat a maths test and the possible score was out of 30, and we've been asked to calculate the range of the pupils' test score. So here we have 10 scores for 10 different pupils out of a maximum of 30, and we have to calculate the range out of this. And these are the steps that we have to follow in order to calculate the range. So first we want to find the lowest number. So we have 23, 15, so 15 is the lowest so far, 29, 25, 26, 26, 20, 18, 24 and 27. So that means 15 was the lowest number out of all of them. And then for the highest number we have 23, 29, so that's the highest so far, 25, 26, 26, 20, 18, 24 and 27. So that means that 29 is the highest number. And now what we must do is subtract the lowest number from the highest number. So that would be 29 minus 15, and that would be equal to 14. So that means that 14 is the range for this set of data, or in other words, the range of 10 pupils' test score. So we can also use things like the range in order to compare the stats between two things. So for example, let's say we wanted to compare two strikers playing football and the amount of goals that they've scored over a course of 6 seasons. So here we have each year or each season that the strikers have played across, and here we have the goals for striker 1 and striker 2 across each of these seasons. And maybe we want to measure who's been the most consistent striker over the course of the 6 seasons, and we can do that using the range, for example. So for striker 1 we can see that the least amount of goals in a season is 5, and for striker 2 that would be 16, and the most amount of goals for striker 1 is 25 in 2019, and for striker 2 that was 20 in 2018. And to calculate the range, it would be the highest number take away the lowest number. So for striker 1 that would be 25 minus 5, so we have 20, and for striker 2 we have 20 minus 16, which is 4. So what this tells us is that striker 1 has a larger range than striker 2, and all that means is the amount of goals that they've scored over a season is more varied, and for striker 2 their amount of goals is more consistent. So even though for striker 1 that they may have had the most amount of goals in one season compared to 25 and 20, but we can see here because striker 2, the range amount of goals they've scored is smaller, so that means that they'd maybe be more consistent and more reliable of scoring goals for a specific football team. Now that's just a very simple example of how we can use the range to compare data, and of course if we wanted to do a more complex analysis, there's many other things that we have to consider. But the range is a useful tool nonetheless when we want to address how spread out data is or how close it is together. So let's go over a quick recap of this lesson. So we said that a frequency table can be a good tool to help us organise and order our data, and it consists of a left hand column listing all the things that we are measuring, and a right hand column which contains the frequency, which is just basically how often something occurs. And we have to decide what the rows should be, either just a single number or maybe a group of different numbers depending on the range of the numbers. So if it's a very big range, then we may want to group things together, such as an age range, but if it's something small, like maybe a shoe size, then it would be okay just to have individual numbers listed. And as I just mentioned, the frequency by itself is how often something occurs, but the cumulative frequency would be a running total of the frequency, so adding up each frequency as we go down each row. And finally, we said that we can use something called the range to measure how spread out our information or data is. And the way we calculate the range is just simply the difference between the highest number and the lowest number within that set of data. And if the range is bigger, that would mean that our values are more spread out. And if the range is smaller, that means that our numbers are more consistent and closer together. So that's us just about to wrap up this lesson on statistics. If this has been helpful to you, make sure and give the video a thumbs up. And if you have any questions on it, be sure to just comment down below. And if you'd like to see more content like this, make sure you subscribe to our channel, or you can head over to our website at penguin-learning.com. Thanks again for watching, and I'll see you in the next video.